The following lesson is going to cover predicting the products of chemical reactions, and this is going to build off of our previous lesson that dealt with reaction types. So the steps for predicting the products of a chemical reaction is first to identify the type of reaction that's occurring by looking at the reactants, and I'm going to show you some of the tricks and things to look for in order to identify that particular reaction type. We're going to predict the products based on that type of reaction. We're going to write the formulas for each product, taking into consideration the type of compound. For example, if it's an ionic compound, you have to consider the charges and write the formula after crisscrossing and simplifying. And then also we have to pay attention and look for diatomic elements that might be produced because we write them in a special way. And finally, we're going to balance the chemical equation. Okay, so diatomics. Anytime you see hydrogen gas written, nitrogen gas, oxygen, fluorine, chlorine, bromine, or iodine, make sure to write those with a subscript of 2 because they exist with 2 atoms bonded together in their elemental form. So we have to keep that in the back of our minds when we're writing products. Also, remember your polyatomics. You're probably going to want to use your sheet or the 10 that you had memorized. These are the 10 that you've memorized here on the list. But if you don't have it out, definitely take out your polyatomic ion sheet. It will be very helpful in predicting products and writing formulas. Okay, for a synthesis reaction, first thing you need to do is look at the reactants, and we notice that we've got elements. 2 elements and that's the indication that this is going to give you a synthesis or combination reaction. So look, sodium's a metal. Chlorine gas, that's a nonmetal. So we're going to end up with an ionic compound. Okay, so what we have to do is, after we've identified that our 2 elements are a metal and a nonmetal, we're going to write the charges for each. Use your periodic table. Sodium forms charges of +1, chloride forms charges of -1. And our formula for the new compound, after crisscrossing, we get NaCl. All right, so we put our formula, NaCl, and then the last step is we're going to balance. And we should all be proficient in balancing equations at this point. All right. So I want you to pause the video and I want you to give this a try. You should have the notes out in front of you. So in the synthesis practice problems, I want you to do these problems. When you're done, resume the video and I'll show you the answers. All right, hopefully everyone was able to give this a shot. We notice that we have 2 elements. We have a metal and a nonmetal element. So we're going to be getting an ionic compound. So we have 2 elements. Now we have to consider their charges. Aluminum will form a +3 charge. Iodine forms a -1. So when we crisscross, we get Al(I)3. Let's balance. We see our iodines, we have a 2-3 combo, so let's think 6. So that becomes a 2, that becomes a 3, and that becomes a 2. Right, now for a word problem. Calcium metal, that's the elemental form. Calcium, no ions. That has a charge of 0. All elements have a charge of 0. Reacts with nitrogen gas. That's a diatomic. Anytime you see nitrogen gas, we're writing N2. So we have a metal and a nonmetal elements. They're going to form an ionic compound. Let's consider the charges. Calcium forms charges of +2. Nitrogen, when it forms compounds, becomes the nitride ion on your periodic table. That's a -3. Crisscross, we get Ca3N2. And now we balance. We just have to put a 3 out in front. Next, we have decomposition reactions. A decomposition reaction always has a single reactant. That's how we know it's going to be decomposition, because you have one thing on the reactant side, the left side. We're going to do simple decompositions. We're just going to break the compound apart into its elements. That's it. So you have one compound, you're breaking it into its elements. Let's look at some examples. We'll take magnesium oxide, break it into Mg and O2. Don't forget, oxygen is a diatomic element. In its elemental form, you have to write it as O2. We balance. Oh. And the next one, we have H2 plus I2. And we balance them all. So these were relatively easy, but we had to pay very close attention to those diatomics when we write them as products. All right, so I want you to pause the video and give the practice problems a try. And when you're done, resume the video and I'll show you the answers. All right, hopefully everyone had a chance to give these a try. We notice that it's a decomposition reaction because we have one thing on the left, one reactant. So we're just going to break it into its elements. Let's break it into elemental magnesium metal and chlorine gas. Elemental chlorine is a 2. Now, chlorine gets a 2 there for a different reason that it gets a 2 there. It's a 2 in the reactants because we got Mg plus 2 and Cl minus 1 when we crisscrossed. All right, that shows us that we need 2 chloride ions to give a neutral ionic compound. However, it's a 2 on the right because it's a diatomic. Subscripts do not transfer from reactants to products. You can't just blindly write it as a 2 because it appeared that way in the reactants. All right, now let's try a word problem. It says sodium iodide. Well, that's an ionic compound. Sodium is a +1. Iodide is a -1. So we get NaI. Let's break it into its elements. Sodium metal, and I hope you recognize that iodine is a diatomic. Now we have to balance 2 and 2, and we're done. Let's look at single replacements. Okay, you know the general format is A plus BC, and we can get two products. Remember we talked about we can get AC or BA, depending if the element is a metal or a nonmetal. We're going to look at both examples. So BC is an ionic compound and A is some kind of element. We have an element and a compound. If the element is a metal, then that metal will replace the other metal or the cation. So we do the switch and we get our replacement products. And notice how we consider the charges. Zinc always forms a charge of +2. Sulfate was a -2. We do the crisscross and simplify. That's how I got the zinc sulfate. If the element is a nonmetal, on the other hand, the nonmetal will replace the nonmetal element will replace the nonmetal in the compound. So iodine is replaced by fluoride ions. Don't forget your diatomics, and don't forget to consider the charges every time you write the formula of a new ionic compound. and then we balance finally. All right, I'd like you to pause the video and give the next two problems a try. When you're done, resume the video and I'll give you the answers. All right, now in our first problem, our element is a metal. All right, so that means that the metal is going to replace the metal of the compound. Now we have to consider the charges when we write the formula of a new compound. So zinc always forms a +2. Chloride is a -1. Crisscross and we get ZnCl2. And copper is now written in its elemental form. No charges. It has a charge of 0 in its elemental form. And that one's already balanced. Let's try the next one. Liquid bromine. Well, that's an element, and we know that bromine is one of the diatomics, so let's write it as Br2 is added to a solution of aluminum iodide, Al I3, right? Because aluminum has a +3, iodine is a -1, and we crisscross. So I'm recognizing this as an element and a compound. I know a single replacement reaction is going to happen, but in this case my element is a nonmetal. So that nonmetal is going to replace the nonmetal in the compound. So let's write the formula for the new compound that's going to contain aluminum ions and bromide ions. I get AlBr3 plus iodine has been replaced and it becomes elemental iodine. Don't forget, iodine is a diatomic. And then we balance. So we have, for bromine, I have a 3-2 combo, so let's think 6, 3, and 2. If we fix the aluminums, I get 2, and then for the iodines, we'll make that 6. Next, for double replacements, the general formula involves 2 compounds. Now we are going to talk about some special examples later at the end of the lesson, but for right now, let's go with the simplest double replacements, which are going to involve 2 ionic compounds. And we need to make sure we're considering the charges every time we write the formula for a new compound. For example, for lead nitrate, we have lead ions and nitrate ions. For Ki, we have potassium ions and iodide ions. So when they switch, if you remember, we do outside, inside. So lead is going to go with iodide, and K is going to go with nitrate. So we write our products. We switch the partners and rewrite the new compounds. We get PbI2 and KNO3, and finally we balance. Okay, give these a try, and when you come back, I'll show you the answers. All right, so let's look. Our general formula, we have 2 compounds, 2 ionic compounds, A, B, C, and D. We know that A is going to go with D, and B is going to go with C. So let's consider our charges. We have Pb +2, NO3 was a -1, lithium is a +1, PO4 was a -3. So lead is going to go with phosphate, lithium is going to go with nitrate. So lead with phosphate we get Pb3, PO4 2, and then we said lithium was going with nitrate, Li plus 1, plus nitrate, NO3 minus 1. Do the crisscross, you get LiNO3. And now we balance our nitrates. If I make that a 2, then my lithiums, I'd have a 3-2 combo. So we have to think 6 here. We have a 3-2 combo, think 6. So I want to make 6 nitrates. If I put a 3 out in front of there. So my nitrates are good. Now look at my lithiums. I have 6 lithiums. If I put a 2 out in front of there, my lithiums are good. Now my phosphates on both sides both have 2. And let's go back to the leads. You notice that there's 3 leads on both sides. For the next problem, we have sodium hydroxide. So sodium is Na plus 1. Hydroxide, OH minus 1. So we get NaOH is added to iron 3 sulfate. Well, iron 3, Fe plus 3. Sulfate is SO4 minus 2. And then we crisscross and we get Fe 2 SO4 3. Okay, so those are the reactants. We have 2 ionic compounds. Well, they're going to switch. So we're doing outside, inside. Sodium will go with sulfate, iron will go with hydroxide. And that gives us Na2SO4 plus FeOH3. Now we can balance, and we're going to end up with another 3-2 combo. So that's going to have to be 6. That's going to have to be 3. And that's going to have to be 2. Combustion reactions. These ones are pretty easy. They always involve some hydrocarbon, which can also have carbon, hydrogen, and oxygen. It doesn't always have to be carbon and hydrogen. And this hydrocarbon is always reacted with oxygen. That's how you know it's going to be a combustion reaction. So your products are always CO2 and H2O. These are easy. You write the same products every time and then balance. So we have a hydrocarbon with oxygen, and we write CO2, H2O, and then balance. Okay, let's try the next 2 problems, and when you come back, I'll give you the answers. Okay, we notice we have a hydrocarbon and oxygen. Don't mistake this for a single replacement. I know that you have an element in a compound, but this is a special scenario. You see that hydrocarbon and oxygen, you know it's got to be combustion. The products are always CO2 plus H2O. We can balance our carbons first, so we put a 3 on both sides. We can balance our hydrogens. That gives us 8. And finally, let's balance our oxygens. Well, there's 10 oxygens on the right. If I put a 5, then we get our 10 and we're balanced. Next, let's try hexane. So hexane has 6 carbons. And remember the formula C to the N, H to the 2N plus 2. That means we have 14 hydrogens. It's burned in the presence of oxygen. So that's what we're given, a hydrocarbon and oxygen. Products are always going to be CO2 plus H2O. All we have to do is balance. So let's take care of the carbons first. That's 6. Let's take care of the hydrogens second. That's 7. All right, now my oxygens on the right side, I have 12 plus 7 is 19. So 19 divided by 2 is 9.5. So we're going to put that 9.5 oxygens in here. And the trick was we just double everything. And now we're balanced. Okay, next we're going to learn some special reactions that all fall under the category of synthesis, decomposition, single, double, or combustion. However, these are specific ones that show up time and time again. They're quite important. I'm not going to ask you to memorize them, but you should be familiar with them. All right, I will give you the sheet, so you got to know what you're looking at. The first type is a nonmetal oxide with water. This always produces an acid. So, look, carbon dioxide. You have a nonmetal oxide reacted with water. It produces H2CO3. That's carbonic acid. Let's look at another one. Sulfur is a nonmetal. SO2, sulfur oxide, sulfur dioxide. You have a nonmetal oxide in water, and you get H2SO3. Now these are easy to write the formulas for. We just smush everything together. So look, you have 1 carbon, 3 oxygens, and 2 hydrogens. Next is an active metal oxide. Active metals are your group 1 and 2 metals, alkali metals and alkali earth metals. Anytime you mix an active metal oxide with water, we're going to get one of these special synthesis reactions where we get a metal hydroxide. And we saw this in our lab when we mixed magnesium oxide with water, we got magnesium hydroxide. Here we have potassium oxide and water, we get potassium hydroxide. Another special synthesis, we also saw this one in the lab. A metal plus oxygen gives a metal oxide, like zinc plus oxygen gives zinc oxide. The special single replacement that you want to know is an active metal, group 1 or group 2, plus water gives a metal hydroxide plus hydrogen gas. So when we're predicting these, when you see an active metal plus water, it's often helpful to think about the water as HOH, and the metal will always replace the hydrogen. You see how we get the calcium hydroxide and then hydrogens by itself written as a diatomic? All right, and the last special reaction type is just a double replacement, but it involves an acid and a base. Now, bases are just metal hydroxides. They make the solutions basic by increasing the hydroxide ion concentration, which raises the pH. That's going to come in later chapters. However, metal hydroxides are bases, and you know your acids now. Anything with an H first here. So we just do exactly what we did with our double replacements. It's outside, inside. But notice how that outside, we have H and OH, that forms H2O. So an acid and a metal hydroxide base always give a salt, which is just an ionic compound, another name for an ionic compound, and water. So let's look, outside, inside, we said we have the water, and there's our inside, calcium sulfate. You consider the charges and write the formulas. And now we have A, B, C, D, outside, inside. We get aluminum acetate and water, and then we balance. Let's look at some examples. The first one, I see I have a non-metal oxide plus water. So this is easy. Non-metal oxide plus water should give us an acid or an oxyacid. And writing the products is easy. We're just going to smush these two together, writing H first. We have H2, there's 1 carbon, 3 oxygens. And this is already balanced. For the next one, I've got an active metal. That's potassium's group 1. That's an active metal. Plus water. This is a special single replacement. So we can think of water as HOH in this case. Potassium is going to replace the hydrogen, and we're going to get a metal hydroxide plus hydrogen gas. So that's KOH plus H2. Now I can balance this. Let's do the hydrogens first. 2 hydrogens. We can fix our hydroxides, and then we fix the potassiums. If I take a metal oxide plus water, this is a special synthesis. We saw this one in the lab. We get magnesium hydroxide. Metal oxide and water gives the metal hydroxide. And that, I believe, is already balanced. Yep, 2 oxygens, 2 hydrogens, 1 magnesium. Give the next 2 a shot. When you come back, check the answers. All right, for the first one, we have a metal plus oxygen gas. This is going to be a special synthesis. We're going to get a metal oxide. Now, we saw this in the lab too with magnesium and oxygen. Aluminum forms a +3. Oxygen forms a -2. So when you crisscross, we get Al2O3. And if I put a 2 and a 3 and a 4, then I'm balanced. In the last type, I have an acid plus a metal hydroxide this is going to be, we have a compound and a compound. This is going to be a double replacement, but this is your acid-base reaction. And we're going to get a salt and water. Acids and bases react in a neutralization type reaction to give us salt and water. So there's your water, H and OH. And your Na3PO4, right? Na is a +1. Phosphates PO4 -3, so you get Na3PO4. And you see how the H will combine with the OH? You can leave it as HOH if you want. This is going to help you to balance it. All right, now if we want to balance, let's take care of our sodiums first. Let's fix our hydroxides. I've changed the hydrogens. Oh, look at that, it's already balanced. So, these are the special reaction types. Again, you will have a sheet to work off of. You don't have to memorize them all, but we need to be familiar with them. All right, and this concludes the lesson.